Hello everyone, welcome back to another video on organic chemistry. This time we are going to look at the chapter on alcohols. So alcohols is the next homologous series of the alkanes, alkenes. Now we have alcohols. Now alcohols is a homologous series which is characterized by the OH functional group. So whenever you see an OH on an organic compound, we know that this organic compound is alcohol. Let's look at the table concerning the different types of alcohols. In this table, we're going to look at the different alcohols that we have, depending on the number of carbon atoms that is present. For example, if the number of carbon atom is 1, the name is methanol. This is a displayed formula. It contains 1 carbon, so 3 hydrogen bind directly to the carbon and 1 OH group here. The structural formula is CH3OH. Ethanol has 2 carbon, CH3, CH2OH, CH3, CH2OH. If we look at propanol, it's a third member of this homologous series. It contains 3 carbon atoms, 1, 2, 3. So it's CH3, CH2, CH2OH. If we have 4 carbon atoms, then we have butanol. This is a displayed formula for butanol, CH3, CH2, CH2, CH2OH. Now instead of writing CH3 and CH2, CH2, CH2OH, we can just write CH3, and then we have CH2 3 times. We just write in brackets CH2 3 times OH. In the next part here, we're going to look at the chemical properties of alcohols. We have seen that each homologous series, such as alkanes and alkenes, shows some unique types of reactions. Alcohol as well shows some reactions which is kind of unique for itself. But in general, all members which we have seen has undergone combustion, such as alkanes, alkenes, and now alcohols. And if you remember well, what is combustion? Combustion is a reaction in which if you take an organic compound and burn it in the presence of oxygen, it's going to give you carbon dioxide, water, and heat energy. Okay? This is the first thing about alcohols. Alcohols can burn in the presence of oxygen to give you carbon dioxide, water, and a lot of energy. Now, what is the application of this? What is the implication of this? Since the burning of alcohols produces energy, alcohols can be used as a source of energy. The second reaction we are going to look at is oxidation reactions. Now, what is oxidation? Oxidations are reactions in which you add oxygen to a compound. If you oxidize alcohol, that alcohol is converted into a carboxylic acid. So that's it. We can oxidize an alcohol into a carboxylic acid. Now, what do we need to carry out this oxidation? Any oxidizing agent will do, such as, for example, we can use potassium dichromate or we can use potassium permanganate. Here is one example. If we take ethanol and we oxidize it using potassium permanganate or potassium dichromate in an acidified condition, the alcohol changes and becomes a carboxylic acid. In this example, ethanol is changing into ethanoic acid. You have to note one thing, 2 things in fact, or 3 things shall I say. The oxidizing agent which you are using should be in acidic medium, it should be acidified. The second thing is that when you carry out this reaction, you need to warm it. So you need an acid in this condition. First condition. Second condition, you need to warm. And the third thing which you have to note, during this oxidation, the color of the oxidizing agent will change. For example, potassium permanganate will change from purple to colorless. If we are using potassium dichromate, the color will change from orange to green. And this is how you're going to know if it is an alcohol. If you want to know it's an alcohol, you heat it with potassium dichromate or potassium permanganate, the color has to change. If while you're heating an alcohol, or if you're heating a substance with potassium permanganate or potassium dichromate and the color does not change, now you know there was not an alcohol there. In this next part, we're going to look at how we can form alcohols. There are 2 ways in which we can make alcohols. The first is by the catalytic hydration of alkene using steam, and the second is by the fermentation of glucose. Now, at this part, we are going to look at the catalytic hydration of alkenes. So if you remember, alkenes contains a carbon-carbon double bond. Across this carbon-carbon double bond, you can add water. For example, if you take water and you split water, we are going to get H, and then we are going to get OH minus. Now, that H can come here, whereas the OH can go and be added to the other part of the bond. This will give you, from an alkene, we will have this. If the OH adds here, becomes OH, H, 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 and H. So this is an alcohol, right? So by adding steam or water across a double bond, an alkene can be converted into an alcohol. Now, there are some specificities about that reactions. As you know, in organic chemistry, you should also know about other conditions for other reactions to happen. If you want to take an alkene and you want to convert that alkene into an alcohol, what you need as condition, you need a high temperature, you need a high pressure, and also very essential is you need phosphoric acid as a catalyst. So if you see, these two conditions are needed for alkenes to be converted into alcohol. Now, this is in general how the reaction occurs. More specifically, if we consider, for example, ethene, and we add steam across ethene, then the ethene becomes ethanol. In the next part, we're going to look at the second way in which we can make alcohol, that is by fermentation. What is fermentation? Fermentation is a process during which, when we take glucose, we can convert it into alcohol. The process by which it occurs is called fermentation, and there are some specific conditions by which this will occur. For example, you need yeast. Yeast contains some enzymes, and it is these enzymes which can convert glucose into alcohol. Secondly, you need a warm temperature of about 37 degrees Celsius, because yeast is an enzyme. Enzyme works best at around 37 degrees Celsius. No oxygen should be present because this is an anaerobic reaction. Yeast is an anaerobic. No oxygen is therefore should be present. This is a general equation for what happens. Glucose during fermentation becomes ethanol, and carbon dioxide gas is also produced. Let's look at, this is a word equation. Let's look at the chemical equation. This is a chemical equation for glucose, which becomes ethanol and carbon dioxide. Now, what's the application of fermentation? Because we can use glucose and convert it into ethanol, and ethanol can in turn be used as a form of energy, we can produce glucose from photosynthesis. So this means that this whole process of photosynthesis can be used to make glucose, and then the glucose can be fermented into alcohol, and then the alcohol can be used as a source of fuel. Don't forget that nowadays we have a problem at the level of the fuel which we use. Petroleum is going to end one day. So what we are going to do, scientists is constantly looking for new methods in which they can produce energy sustainably. For example, if you consider petroleum, it's not long lasting, it's not renewable. One day it will end. So scientists is looking for new ways in which we can generate energy continuously. One other source of energy which is constantly available to us is the sun. Now, if we have the sun energy all the time, using this energy from the sun, we can make photosynthesis all the time, and from this photosynthesis, glucose is made, for example, in sugarcane, right? And then we extract that juice from sugarcane, we let it fermentate, and then we get glucose, and then this glucose we can use to make fermentation, and then from fermentation we get ethanol, which we can use as an energy source all the time. We now come to the last part in alcohol, and in this part we're going to look at some functions of alcohols. There are three main functions which you need to know according to your syllabus. The first one is that alcohols can be used as a source of energy. Don't forget, in the first part we found that when we burn alcohol in the presence of oxygen, it forms carbon dioxide, water, and heat energy is produced, making it suitable as a source of fuel. But the advantage of using alcohol as compared to petroleum is that it can be generated from fermentation of glucose, and the glucose in turn is obtained from photosynthesis and therefore becomes a renewable source of energy. The second part in which we can use alcohol as a solvent for many important reactions. For example, we can use alcohol as a solvent in paint, varnishes, etc. The third important use of alcohol is using alcoholic beverages such as wine, whiskies, beers, etc. Okay, so how we make wine, for example, we take the juice of grapes, which is rich in glucose, and we let it fermentate, then it becomes wine. This is how wine and how even beers, etc. are made. So that's it, that's all for alcohol. We will see you next time for another video on the next part in organic chemistry. Till then, bye, take care, and don't forget to subscribe to continue to get more of the videos which I will upload. Till then, bye bye.